Buongiorno baddies, welcome back to another video from number 24 of the 2023 AMC8. Isosceles triangle ABC has equal side lengths AB and BC. In the figure below, segments are drawn parallel to AC so that the shaded portions of triangle ABC have the same area. The heights of the two unshaded portions are 11 and 5 units, respectively. What is the height of H of ABC? So, when we first look at this problem, there is a certain property to these two triangles. So let's just talk about like triangle this funny little triangle, and this big little triangle. This big little triangle, okay, whatever. So basically, like I explained in a previous problem in this exact same year set, in problem 19, the sides of a triangle have the same, have a square relationship if the two triangles are similar with its similar triangle. So in this case, it just so happens that the height also works the same way, but the triangles have to be similar. And in this case, the triangles are indeed similar. So this means that if we take that funny little relationship and cheese it for all that it has, we basically find that we can actually write an equation with this. So let's just look at these two little shaded portions real quick. So this funny little shaded portion and this funny little shaded portion. How are we going to squeeze out the area of these two shaded portions? Well, we won't, but we can indeed actually find an equation for them. So let's just look at this original little triangle here. This. Okay, so let's just say that the area of the whole triangle, the entire triangle ABC, is equivalent to S. So S minus this little triangle is equivalent to this trapezoid, right? And obviously we're not going to go for the area of the trapezoid because obviously that would be a pain in the butt to do because we don't know what the lengths of either of these triangle sides are. So we can just calculate the area of the small triangle and subtract it from the total area. So we basically have 11 over h squared multiplied by s, utilizing the square property, is equivalent to the sides, this funny little thing. And we don't have an s minus here because the only reason there was an s minus on our first one was because we were trying to calculate the cyan circulated trapezoid and not the actual triangle itself. But in this second triangle, we are actually trying to calculate the triangle itself. So we do not need an s minus. So h minus 5 over h, because the height of the bottom trapezoid is equivalent to 5, and the total is equivalent to h, therefore h minus 5 squared multiplied by s still. So we have our equation now after utilizing and milking the entire thing for all that it's worth, and now that we just need to solve. Dividing both sides by s, we find that we have 1 minus, and opening the parentheses to the square, 121 over h squared is equivalent to h squared minus 10h plus 25 over h squared. Okie dokie, so now that we've already simplified the equation to this stage, we can multiply both sides by h squared, getting you so that these two are gone, this is equivalent to h squared, then subtract both sides by h squared, so we have this. And then we move the 10h to the left side and the negative 121 to the right side. So we have something that looks like this. 10h is equivalent to 121 plus 25. 10h is equivalent to 146. H is equivalent to 14.6. Funny! Okay. So that means that the answer to this problem is A, 14.6. So yeah, that's the end of this video. Hope you guys enjoyed, and I'll see you all on the next one. Bye-bye!